So we're studying Boyer-Moore, and we have our bad character rule and we have our good suffix rule. And so far we've used them separately, but in practice we're going to use both of them together. So basically whenever we have a mismatch, we're going to try both rules. And each rule will tell us some amount that we can shift the pattern P, in other words, some number of alignments that we can skip, and we're simply going to take the maximum of the two. So let's use them both in an example. So let's say that this here is our first alignment of P to T. The very first character comparison is going to result in a mismatch. This G in the pattern mismatches this T in the text. So since no character is matched, the good suffix rule is not applicable here. There's no matching characters, so we can't use the good suffix rule. We have to use the bad character rule. So what does the bad character rule say? Well, it says that we should shift until this highlighted T here is underneath this T here. So this skips 6 alignments. So it shifts P over by 7 positions, or it skips 6 alignments. And the good suffix rule doesn't skip at all because it's not applicable. So we're going to use the bad character rule in this case, and we're going to skip over 6 alignments. Okay, so let's do that. Here's our next alignment. We've skipped over 6. So here we get some matches. So we have our mismatched character here, and we have our small t, the stretch of characters that we matched within the text. And so if we use our bad character rule, it's going to tell us that we can't skip any alignments, because as soon as we shift P over by 1, this C down here that's highlighted in purple comes underneath this C right here. So the bad character rule doesn't skip any alignments. The good suffix rule does skip some alignments. So this is GCG, this is the string of characters that we matched within T. There's another occurrence of GCG right here. So the good suffix rule is going to let us skip 2 alignments. We're going to shift P over by 3 characters. So we take the maximum, and we shift P over by 3 characters, skipping 2 alignments, and we get this. So in the next alignment, the bad character rule will skip 2 alignments, where the good suffix rule will skip 7 alignments. So we're going to take the good suffix rule, and that gets us to this point here. So we just saw 3 steps where we used the bad character rule and the good suffix rules together, and we'll implement this in the upcoming practical session. So you might wonder, how much of an improvement is Boyer-Moore over naive exact matching? So in this example, we went through a few steps of Boyer-Moore and we skipped a total of 15 alignments. So furthermore, there were several characters in the text, these characters highlighted up here, that we completely ignored. They were never involved in any character comparisons that we did. This explains Boyer-Moore's advantage over naive exact matching. Even in the best case, naive exact matching is never going to skip an alignment, and there's never going to be a character of the text T that it fails to examine. So in practice, we do expect Boyer-Moore to be substantially faster, and this is generally true, and we'll explore this a little bit in the homework in this module.